Equilibrium.
What?
Nothing.
You haven't asked Nino to play.
Oh, there you go, Nino. He gets on camera. Let's see the flex. The flex.
I'm not gonna flex for you.
The flex.
What do you want?
No flex.
I'm not that kind of person.
Come on.
You gotta jump for that one.
Come on, Nino.
Wait, Nino, which arm is better?
I don't know.
Right arm. He's a righty.
What?
All right, Nino. Very good. Equilibrium.
Punching.
What does it mean to be at equilibrium?
Balance.
Not balanced.
Not balance.
That has nothing to do with it. To do the little thing like this? No. That looks pretty cool on the camera.
It means where I don't know explain, but the two things meet and they stay the same. They don't change.
They stay the same. What stays the same?
Can I do
The
that?
concentration.
No.
I said it like 5 times.
Oh, okay.
You said it 5 times.
Can I do that on camera?
Okay, great.
Am I allowed?
Okay.
Am I allowed?
So
No.
the equilibrium is when all the concentrations stay the same. Now it could be true that a certain chemical has a really low concentration, right? But as long as it doesn't change its concentration, it's not going to be I'm totally distracted by what happened right here. Are you okay?
Yeah.
Okay.
I hit my
As long as you don't change the concentration, it's at equilibrium still. Okay? All right. That's equilibrium. To calculate the constant at equilibrium, KEQ.
Is 20 2/6 or 1/6?
20? Just 20 is 1 sigma. Without a period.
And if it's like 0.034, the 0 does not count. Right, Mr. Sanders?
0.034. That's right. Okay. A is right here. B
Where is it? Oh, sorry.
Right. An equation like this, where you have little a, big A, plus little b, big B, sometimes that gets confusing what the heck that really means. Right? So what this really means, the little a's are the coefficients in front of all of the chemicals. So if you have an example, I like to give a simple example for this one, so it shows that this is pretty flexible. If you have an equation like this, H2 plus O2, and that's in equilibrium with H2O. First of all, it's not balanced, we're going to balance it, so I'm going to do this and that, and now it's balanced. Okay. So if I have an equation like this, I put it into the KEQ equation right here. This is the equilibrium constant. So now C, well, that's the product over here. So C is the product. I'm just going to put in H2O. H2O, whatever that concentration is, and it's going to be squared. Because there's a 2 in front of the H2O over here. There's 2 H2O molecules. Now, down below, we have both of these reactants. So it's going to be H2, the concentration of that, whatever it is, squared, times
Squared.
O2. And that's not squared. Because there's only,
There's no number of
you can think of it as a 1 right there if you like, but it's not. You can do anything. So, if I give you the values for all of these, you could figure them out.
Yes.
Yes.
I'm confident you could do that.
Hopefully.
Okay. As they say, it's a plug and chug, where all you have to do is you have to plug in all the values for these things. If I say H2O has a molarity of like 3 molar, H2 has a molarity of like 2 molar, and like O2 has a molarity of like 1.5 molar, then you can figure out, just by putting these numbers in here, what this answer is. Okay?
And then,
You can figure out what the KEQ is. Yeah.
And then if you give us, once we figure that out, the like that's like part A, and then like part B would be like you like change like 2 of the numbers.
Yeah.
Like you change like H2O and H2, but not O2.
Right.
So what would for that you would keep like the KEQ that you found.
Right.
Change the like new number for H2O and O2 and H2, and then for like O2 you would use like X or something.
Yes.
Oh.
Yes. So for the next follow-up question, which is almost always the case, this is the follow-up question, I'd say, what happens if we change the concentrations now? And let's say, after you figured out the KEQ for this one right here, which is the equilibrium constant, right? tail. All that sound shows up.
Oh.
And it gets distracting when
Sorry.
trying to listen to this stuff. We've got, once we figure out the KEQ here, I can change these numbers and leave, let's say, O2 blank. Okay? I can change it. So like at stress, let's say now the new stress is H2O is 4 molar, and let's say now that H2 is 3 molar, and now I want you to find out what O is. We don't know what that is. So what you'd have to do then is you plug in this value now for the H2O. You plug in this value for the H2, right there. You'd use the KEQ that you've just found in the previous problem, whatever that was, and then you'd solve for this O. You could put an X in there if you want to, or whatever. You just have to solve it algebraically. Now this time, sometimes people have a real big problem with just solving this with algebra. But for that, it's just a simple multiply both sides by the denominator and then divide whatever is multiplying this. Yeah?
Should you keep the exponent?
Yes, you keep the exponents, always. The
Always keep
exponents.
the exponent?
Yes.
So if you did like, okay, so like H2 in the beginning was, I have no idea what it was. But
Yes.
now it's 4, or now it's 3.
Right, it was 3 squared, but then when I have a new concentration
So
here,
now it's 4 squared?
now it's 4 squared, yes.
Okay, so so oxygen wasn't squared. Wait, oxygen wasn't
No.
So now oxygen, let's see where oxygen is. You know, it's right there. So that, was it squared before?
No.
No, it was not squared. So you
No,
don't square.
no.
Right, but what if it was, what if it had a 3?
If it did have a 3, let's just, hypothetically, if this had a 3, right, this, if it was a 3, that would mean that this would have to have had a 3 right up over here, right? If it did, then that would be an x to the third.
Okay.
Yes, and you have to solve for that. There we are. Okay, good, thank
Fantastic.
you.
You know.
Yeah.
My question is, like on the quiz, I set it up right, so that I accidentally flipped it. So usually the two things on the left side of the arrow sign would go on the bottom because it's A.
Yes.
All right. So A, like when we did that exercise, A, B, C, D, and then A. And B.
Yeah. Oh, great. I'm glad. I almost forgot to bring this point up. Down here, these are the reactants, right? Up here, these are the products, right? If we had another reactant over here, where would that go? Would that go up here, or would that go down here?
Down there.
It'd go down here. It would be down at the bottom. If we had another product, let's say we had 2 more products, it would go up here, right? So this is just an abstract way of showing this. You can have more or less products or more or less reactants as well. Just add the reactants down here. I'm sorry, multiply the extra reactants over here and multiply the extra products over there. Now, what happens if KEQ is greater than 1? Okay? This equilibrium constant, what does that mean in our little reaction here? If this is greater than 1, then that means there's more products. That means there's more of these things over here. And that should make sense to you, because that means that this number is larger. So this whole equilibrium favors, they say, favors the products. There's more products being made. If it's less than 1, what does that mean?
More reactants.
Yeah. If it is 1, then it's absolutely equal. It's the same. It's not. There's no favoring either way. Okay.
I got it at like equals to 1.
That would be really tricky, wouldn't it?
That would suck.
Yeah. Yeah. Okay, that's equilibrium. Le Chatelier.
Okay, I got it.
You want to erase? Well, be on camera. There you are. Le Chatelier. Endo exo.
Jump, Nino.
I'm not gonna. I forgot the jump. Red tail, carry me. No, you don't want to. Okay. Nice. Thank you.
Gonna be the first review.
Tail was like looking at the camera when he was it.
Le Chatelier. Le Chatelier. Let's use. What did we use yesterday? We used the FE and the SEN. But let's use a packet that we went through yesterday. Let's use one of those questions. Okay, one of the questions that you're confused about. Not the workbook, but the pack. We had like a little handout.
This thing?
Yeah, that thing. Which one? Which is a problem you want to go over?
Number
Yes.
1.
Four.
Let's do 4. Can I see that real quick? So here's a problem. It's 2HCl. 2HCl. It's going to be added to Mg, and it's in equilibrium with MgCl.
This is it.
2.
This is the shut there.
And H2 and heat. Okay, there it is. And the question says, when the temperature is decreased, the following system at equilibrium does what? So you decrease the temperature over here. What does that mean in terms of adding or taking away things in this reaction? What would that mean if you're decreasing the heat? Yeah.
So, would the left side would decrease and the
Well, wait, just more immediately, what does it mean to decrease the temperature?
take away.
To take away what?
Stress the reaction.
Yes, you're stressing the reaction. But what are you taking away when you decrease
Energy.
the temperature? You're decreasing the
Heat.
I just want you to say this word.
Heat.
Heat. Yes.
Yeah.
Okay, so you're taking away this. You take it away. That's your stress. You're taking it away. So now the system reacts to this. The system reacts and says, okay, well now we got to get back to equilibrium since part of our product has been taken away. We need to react. So here's how we're going to react. And we've done this before. Okay? Immediately, you can see that there is going to be, how is it going to be less or more of these things? More. They're going to be more left over. And over here, are there going to be less or more of these? Less over here. Okay, so that's what happens at equilibrium. There's less of these things over here, and there's more of these things over here. So the question's a little bit confusing because it asks you, I think it says shifting left or right. What that really means is there more products now, or are there more reactants?
Shifting right.
There's more products, because now we have an extra of both of those, since we've taken away heat.
So, although you take away heat, there's still no products because everything is increasing.
And we do this in industry all the time. To make a reaction have more products, sometimes we want this reaction to make this, let's just say that we really want this, we're a company that sells this right here, and we have this reaction. We want to chill this as much as we possibly can, this reaction, so we can get lots and lots and lots of that.
So, but you're never going to say, like, if we increase or decrease the temperature, there's no heat in it.
I would say I either decrease the temperature or I'd say take away heat. But taking away heat is the same thing as decreasing temperature.
I don't understand like the shift